6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome to summer school version of Mathline. So good to have you all out here with us this afternoon. I am Ernie Roberts, and I am your host for Tea and Learn Mathline Summer School Style. You know, it's warm outside, but it's cool inside where you guys are. Thanks for tuning in this afternoon. It's not a call-in afternoon, but you can still send us those questions and still send us those problems for us to work via Facebook and our email. So always take time to do that for us. We love it when you do that. And of course, we always say it, we love it when you like us on Facebook. And we still do that all summer long. Just can't call in, but we still want to connect back to you, all right? And speaking of connecting, let's see what we've got going on in our show this afternoon that you've tuned in so wonderfully to watch here. Tea and Learn Mathline Summer School, it's all about fraction action part 2, part dos, and subtraction it is, all right? So here we go. What have we got happening? It's all about subtracting fractions. And you know what we've got to do when we have fractions to be subtracted? We've got the common denominator. So let's see what our first problem is going to address here for us. What we got here? Whew! It says using the rectangles below. And these are looking pretty much like rectangles. So you say, well, they sort of look square, Ernie. But you know, squares are rectangles. So we have a real big rectangle. The whole picture is a rectangle. Then you've got these little bitty pieces. And then you can group some of these together. You make all sorts of different rectangles in this picture. But what you want to notice is that we're looking at a specific portion or proportion. I guess a portion of them we would say too, yeah. What is 4 out of 16, 2 out of 8, and 1 of 4? We're hoping to show you and to prove with these rectangles, hey, they all represent the same quantity, all right? So let's play this thing out. Let's see what's going on. First of all, to help us out, let's number these rectangles, the little ones, the smallest ones you see here. Let's number them 1 to 16. And we'll put the evens on the bottom row and the odds on the top. So there goes 3, 4, hey, count with me, 5, 6, 7, 8. And some people say, sometimes your math gets so complicated on there. Just count with me. You're on a roll today, all right? 9, 10. We'll get it all the way up to 16 here in just a minute. 11 and 12, 13, 14, 15, and there goes 16. All right, everybody good so far? Hey, that wasn't hard, was it? Now, what I want us to notice here is that if we were to basically block these things off again, notice I've come up with 16, and they're all equal parts. They're all equal sizes. These are all basically the same area. We've measured them out pretty good, pretty well there. They are in good shape. Now, what we want to do is look and see what would happen if I were to divide them into eighths. Let's suppose I were to put them in eighths. For example, 1 and 2 go together. And that will make a new number down here. Let's see if we can drop that bottom there a little bit. Thank you, guys. Perfect. And this will be our second column. This will be our third column. You get the idea. Count up with me to 8. It looks like we're going to have 8 columns. I hope not. I hope so. Hope not a problem there. That's what really. All right. And there we go. Woohoo. 1 through 8. You've got it. Looking at them. So in other words, we could divide this picture up into eighths, into 8 equal parts. All right. And you know what? How about it? Could I go into fourths if I took 2 columns at a time? Oh yeah, we could break it into 4 equal parts. So you get the idea of what's going on here. That's what I'm wanting us to notice. Now, according to this, we're going to show that 4 out of 16. So I'm going to shade off 1, 2, 3, and 4, those blocks. What I want us to show is that this is the same thing as if I were to take, and you say, how about it? How many columns? 2 out of the 8 columns here, all right? So in other words, I start off with this 4 out of 16. I also look in terms of the columns that I've shaded in kind of this blue-green color. I don't know what it comes over. I never know what it's going to come over on the screen out to you guys, but it's just shaded, just a column where we've got 1 and 2 grouped together, 3 and 4 together, and it looks like we've got about, wow, 2 out of 8 coming out of that, all right? And if you really get interestingly look enough, look at the big block. It's a big block of 1, 2, 3, 4. We can do the block with 5, 6, 7, 8, 9, 10, 11, and 12. There you go. And also 13, 14, 15, 16. So there are 4 big blocks of 4 little blocks within them. And that would be one of those 4 blocks. Now, I'm going to tell you, the whole idea is how we shaded those. It says they're the exact same blocks for all three of these fractions. Now they look a little bit different, but they make the same quantity. We said, well, Ernie, if we didn't have all those blocks and the rectangles, how would we know? How would we know? Well, first of all, we would notice that 4 and 16 are both even numbers. So I can take a quick divided by to both of those. Let's divide them both by 2, since they are. And look what that does. That leads us right to 4 divided by 2 is 2. Got that? Everybody with me? 16 divided by 2 is 8. So we're down to 2/8. So yes, they are. Those two are equivalent. They basically tell us a different way to look, but the same quantity. They're just telling us different numbers, but they still match up as the same quantity. Now, will it go down to 1/4? You betcha. Let's go and divide by 2 again, because I see still two even numbers. And you know what? That takes us right there to 1/4. So there we have it, 2/8. There's 1/4. We start with 4/16. They're all the same. Now you say, well, Ernie, could we start at 1/4 and go back to 4/16? Certainly. You could multiply by 2 and get back to 2/8, or you could really just skip the 2 and just go straight with the 4. 1 times 4 would get you back here. 4 times 4 would get you back to 16. You've got the same story going there, all right? So equivalent fractions, that's the beauty of it. And we've got to have those equivalent fractions in order to get common denominators, in order to do our subtracting fractions. So I want you to understand where it's coming from, what's important. And it's not that hard a concept to wrap your brain around, all right? You see it right there. Just basically different numbers that reduce to the same fraction, basically they have to be equivalent. They've got to be equivalent. Or if they increase in the same proportion. So we're going to play that game. Whatever you do to the numerator, you better do it to the denominator and vice versa, all right? At least when it's multiplying and dividing, that's what we're looking at here. So let's take a look at our first little example problem, all right? Says, starting with, subtract these fractions. All right, we got two nice fractions here, 9/16. Go ahead and write those down at home. Go ahead and write those down at home. And we're going to subtract 3/16. I give a little space because sometimes we may need to adjust things. In this problem, our numerators are different. That's okay. That's okay. The denominators are the same. That's definitely okay. That's what we have to have. We have to have the same denominator. So this problem is relatively simple. We are going to keep the 16. It's like I start out with 9. And did I put a 9 up? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we did it. And we're going to take away 3 of those, all right? So we'll take away 1, 2, 3. There we go. I got 1 finger left, and I got 6 here. Well, 6 altogether, right? So what do we got? 6/16, and that will give us 6/16. Now, that's how we subtract. The next part says we got to reduce. We've got to reduce to the lowest terms. I have 2 even numbers again. Guess what? 2 will divide into both of them. That will lead us to 3/8. So if we take 9/16, we subtract 3/16. We actually have 6/16, yes, but lowest terms, that's where we want to go. How about it? Check, check right there. And it's good for us, all right? That's what we're looking for. That's what we're looking for. So subtracting, reducing. Subtracting and reducing. That's the story of the game plan today. Let's do another one, all right? It says subtract these fractions, reduce them to the lowest terms. This time we're going to use eighths, even a little easier than the last time. So we go with 5 minus 1. Remember the story. Get you written that down over there at home. And we're going to say 5 minus the 1. We're going to leave the 8 alone because it's common denominator. So it's perfect. It's what we want. It's exactly what we want. So now we're going to subtract numerators. 5 minus 1. You never thought you'd get to do that again, did you? And it's going to give us 4. And you could say, well, that's nice. And it is. It's nice. And we recognize that hopefully as 1/2. Some of you say, well, they're both even numbers. We could divide by 2 and get 2/4. But you can keep working on down. We want to go to the, not lower, but lowest terms. And that, dear friends, when we divide both by 4, gives us that 1/2 that we're looking for. So again, you can start with one type of unit. For example, here we have eighths. But remember, like we did on that little rectangle, you can start dividing things out of there when they match up beautifully. And these do. 4/8 reduces just like that to 1/2. So reduced fractions, simplified fractions, we hear both of those words. That's what we're looking for in the final answer, all right? So, got it going today? If I give you the common numbers, boy, it's really easy. But let's say sometimes we don't get the common denominators. Let's take a look at this next problem here. Says to arrange these fractions in order from least to greatest. So I'm going to be looking for the smallest. So you guys at home, go ahead and write it down. Write it down. I got 1/4, got a 1/8, I got 3/8, and then I got 5/16. Now I'm going to look at the biggest number first, biggest denominator I should say. We're going to figure out which one is the greatest in the end, but we've got to get common denominators first. And the least common denominator for this, well, you know, 4 will go into 8. That's sweet. 8 goes into 8. And look at that, 8 goes into 16. So what does that tell me? What's going on here? It tells me 16 is our LCD, our least common denominator. So let's play off that. Let's play off that. Put a 16 down here. Put a 16 down here. Oh, another 16 right there. And pop a 16 in right there. Now, notice we changed 3 of these numbers to become 16s, which means, dear friends, you've got to change your numerators. You've got to change the numerators the same way you did the denominator. You're going to say, well, Ernie, what do we do? Well, we figured out that 16 is what we needed. By the way, we didn't change anything on this, so let's let 5/16 just stay put, all right? You say, well, are you sure about that? I'm sure about that, and I'll tell you why here in just a second. Let's take a look at our first fraction here. It says we've got 1/4 originally. What we did, we asked ourselves, how did we go from 4 to 16? Well, we multiplied by 4. We multiplied by 4. And that means we better do it to the numerator also. Because we can't leave the numerator out. Okay, numerator's in the top, by the way. Some of you are going like, which was which? Numerator on top, denominator in the bottom, all right? So definitely we want to have the denominators the same. The numerators are going to be our final story. They're going to help us figure out what order these things need to go in. Okay, I've got a 4. 4 times 1 gives me 4. Some of you all have already gotten through the rest of the problem. I ramble a little bit. How about it? What are we going to need to multiply this 1/8 by? Well, how about it? We'll put a 2 there. Pop a 2 right in there. 2 times 8 gives us 16. Oh, 1 times 2. You got it. We got a 2 right there. So I already know 1/8 is less than 1/4. In case you were wondering, in case you weren't sure, now you know because 2 is smaller than 4. And it looks like 5/16 is larger than the other 2 pieces, all right? What about this 3/8 moment? Well, let's do the same thing. Let's multiply by 2 and 2. I want you to notice something else here. In the last show that we did on the adding fraction, I emphasized this. I want to emphasize it one more time. Look at this 4/4. You're really multiplying by 1. 4/4, 4 divided by 4 means 1. 1 times 1/4, hey, why not? Use 4/4, 4/16. That's why they're the same. When you multiply by 1, you get the same number back. It just looks a little different, but it still measures out to the same quantity of 1/4. Here's the same story. We multiply by 2 here, 2/2. That's a 1 also. So there we get 2/16. And let's go for this last one since I've left you hanging. I know you guys have already figured it out. 3 times 2 will get you 6. And now you can tell who's smallest, who's largest, and who's in the middle, and what order they come in. Anything you want to know about those 4 fractions, you got it. You've got it. So let's see. Smallest, how about it? This one is one we're going to write down first. And we're going to go back to these 4 values right up there. We're going to use 1/4, 1/8, 3/8, and 5/16 in our final answer. So as we drop our bottom third down here, lower third, let's put them down here. First, I've already said it's going to be 1/8. That's how we write them in order, okay? Now, where do we go next? Looks like 4/16 is our next largest number. Second, so we're going to put it in second place, or second as we go to the largest anyway. It's really not a matter of placing here. It's just second in order here. And then we skip 6/16 because it's a little bit larger than 5/16. So this is our third place guy. And here we go with it, 5/16. And last but not least, definitely not least, it was the greatest, right? So fourth goes to 3/8. So your least, yes, is 1/8. We started off with that. 1/4 comes a little bit to the right on the number line. 5/16, a little smidgen more, and then you get to 3/8. A lot more fractions, I know, before you get to 1, but with these 4 numbers, there you go, in order. How about it? Hopefully you got those right out there, and let's start doing some subtracting. I'm ready to do some subtraction problems with, yes, not so common denominators. Well, we got to look for them. Let's see what we've got here. Let's take a look at our first problem with unlike denominators, all right? So subtract these fractions and reduce the lowest terms. Now, I'm thinking about it. 5/8 minus 1/2. And first of all, in my mind, I'm wanting to know, is 1/2 less than 5/8? It actually is. Yes, it is. That's the thing. First thing you got to think about that. Because, again, well, let's write the problem down and see what we're going to explore here. You want an 8, right? Because 2 divides into 8 evenly. So that's where we got to go. We got to multiply this 2 out here by 4. And we're going to also multiply the 1 up there by 4. Now, 5/8, doesn't need to do anything. It's fine and dandy. What we need to know is how many 8s were here. We got 4 8s. So yes, I can subtract. Now, many of you are watching that are just in 3rd, 4th, 5th grade out there. Some of you adults may be wondering what's going to happen if that had been bigger. We would be worrying about a negative situation. We're not going to deal with that today. That's another show. That's another day. That's another whole lesson about what do we do with positives and negatives. And fractions can have them. They can happen, all right? But what we're going to do today is just keep it positive. We're going to say 5 minus 4, which is easy, gives us 1/8. Because remember, yes, you got it. The 8 just runs along for the ride. Never change your denominator in this subtraction business. Just bring it straight across, and life will be good. It is reduced. It was nice. We didn't have to do any divided by 2s or anything because we have a 1 on top. We're done, all right? We're done on that one. Good problem. Good start. Good way to go. Now, let's go a little deeper. Let's take a little deeper plunge here. Let's see what we got. We got 3/4, and we want to subtract 2/3. Now, folks, I just made a new kind of expression there. 4ths and 3rds. I kind of combine them with fourths. No, 4ths and 3rds, and you can't do that. You cannot make 4ths out of 4ths and 3rds, all right? You got to keep something that goes common to them, all right? Because I'm looking at 3/4, it's a whole different type measurement. If I were to divide up a circle into 4 nice pieces and take 3 of them, and then if I were to divide that circle into just 3 pieces that were equal and take 2 of them, they don't look alike. They don't look alike. And so you can't just say, well, we're going to subtract them with unlike there. We got to make the same thing. We got to get something in common. Nice moment here. Our denominator 3 and 4 makes 12 happen. Those two denominators of 3 and 4 make the 12 happen. How do we do that? When they're right next to each other, you can always multiply them. All right, take that to the bank. They're right next to each other. And when I say right next to each other, I mean the numbers are consecutive integers. You've got 3 and 4. If you had 4 and 5, 5 and 6, just multiply them. You've got the least common denominator, guaranteed. Now, if you have another one out here, you might not need to worry about multiplying it into that final result. Sometimes you're lucky and, well, it'll work right through. So let's keep this in mind. We're going to use 12 because that's what 4 times 3 gives us. So we're going to put a 12 right in there. Everybody good on that? Nod with me. You got it. Now, what change did I make? And I want us to start making these changes mentally. We said 4, and we made 12 happen. How did we get there? We multiplied by 3. Multiplied by 3, right? Everybody nodding with me? Got it? Now, I have to multiply my numerator. Remember, whatever you do in multiplication division, if you're going to do it to the numerator, or if you're going to do it to the denominator, you got to do it to both of them. You can't leave them out, all right? But let's do that mentally. Let's do that mentally. So we said 4 times 3 gave us 12. Guess what? 3 times 3 will give me and you and all of us 9. That's where we want to go. Over here on this side, how about it? Well, we said 3 times 4, all right? And we got to multiply the 4, yeah, times that 2, yes. And that gives us 8. See, you can do that in your head. Do it in your mind, all right? Just got to remind yourself, if I change the denominator, got to change my numerator. Let's subtract. Oh, this one's pretty easy too, isn't it? 9 minus 8 equaling 1. Bring the 12 over for the ride. Small piece. You didn't leave much pie there, did you? Or much of whatever was left behind? Not much at all, is there? 1 out of 12 equal parts. 1/12. There you go. So that's what we got it. By the way, did we make lowest terms? Oh, yes, we reduced right there. 1/12 can't go any lower. Can't take it down any further. And that's our story. That's our story once again. So as you're working through these, first of all, ask yourself, did I get a common denominator? Second, did I remember to change my numerators? Third, after I subtract, can I reduce? Can I reduce? So 3 things to be asking yourself. And if you do that routinely over and over again, you'll get faster and faster, and you're just going to be automatically on it, okay? Good things come to you. It is fraction action, and it is fun, and it is subtraction today, all right, here on T and Learn Mathline. Let's go ahead and look at our next problem here. We're going to subtract some more fractions. This one starts out with 7/8, and we got 2/3 to play along with it. Once again, we're going to try to do this mentally. Everybody with it, get your head going. Get your head gear right around. We're going to wrap around this thing. Exactly. I knew what I was going to try to say. Now, let's take a look at 3 and 8. What do we do with them? We multiply those two together to get an LCD. Now you say, well, Ernie, they're not right next to each other. But you know, with 3 being a prime number, and if 3 won't go into 8 evenly, your bet is, yes, you're going to have to multiply those two numbers to get the common denominator, the least common denominator, in fact. How about it? 24 and a 24 right over here. So far, so good. Okay, we changed them both, right? We multiplied something to get to 24 by through both those denominators. So now what we've got to do is remember what was it and then change our numerator. So again, go mental. Better watch out. Do mental math. How's that? That sounds a little better. 8 divided into 24 goes 3 times. And then 3 times 7, how about it? Give us 21 right up there. Yeah, you got it? That was easy, wasn't it? Know your times tables. I've said that before, right? Haven't I? Those of you who watch Mathline religiously or not so religiously, you probably hear me say, know your times tables. It makes life a lot easier. Mental math, mental math. Now, how about it? 3 divided into 24 goes 8 times, and we got 8 times 2. Put a 16 right up there. Keep that subtract in between because we got to do something with those two fractions now that we've worked to get to them. I'm going to say 21 minus 16, and some of you say, I need to go to the calculator. Think about your money. $21 and you 16 back. You know, I like to do that, get change sometimes. They give me a 5 instead of 5 ones, you know. Give me a 5 or something instead of 4 ones if I want to make a different number or something there. But a $5 bill. So guess what? I just told you the answer, right? 5 out of 24. So again, mental math moments here. And by the way, 5 won't divide into 24. 5 is a prime number. You're finished, okay? You're finished reducing this one down. So works out very nicely. Let's expand. Let's go to a three fraction problem, folks. Let's see what we got here. 7/8, write this one down, minus 3/4 plus 1/8. Now I'm gonna get at you, folks. I'm gonna get you here. Some of you are going like, oh, what do we do? Do we have to add 3/4 and 1/8 first, or do we subtract and then add 1/8? What would my dear Aunt Sally? Multiplication, division, that's easy. Adding, subtracting, that's easy. But the question is, the subtraction comes before the addition. Does that matter? It does. In fact, it matters because they take equal precedence. So you're just going to work this thing left to right. Most people try to jump in there and sometimes miss. Sometimes my dear Aunt Sally gets a little misleading because the AS, the addition and then subtraction. But folks, they're equal left to right. So we are going to start here and we'll finish with the 1/8. All right, so let's go back and review that while we're at it too. So looking what I've got here, I've got 7/8 minus, I need an 8 in that denominator. I can get one because there's a 4 there, right? So let's see, I'm going to put that there so we don't get confused that maybe I was talking about something part of a fraction there. That's going to give us what? 6/8, right? That's 6/8. We will do that and then we'll tack on the 1/8 to it. All right, so let's work it left to right. How about it? 6 minus 6, let's try it again. 7 minus 6, we can get it right, is 1. And 1/8 plus 1 will give us 2/8, which equals 1/4. Did it give us 1/4? Let's see, that bottom will disappear for us just a little bit. There we go, yes. 2/8 because we have 1 plus 1, which gives us 2/8, which equals 1/4. Now, let's take one quick look at what would happen if I put parentheses around it, all right? And that is my last problem we're going to get to on this show. So let's take a look at it real quickly. I've got 7/8 minus, and put in that parenthesis, 3/4 plus 1/8. Everybody always asks me, does it make a difference? Well, let's see. Let's put our 7/8, leave it alone. It's going to be the last thing we do. We're going to go parentheses first because we please excuse, right? We got to do those first. It's going to be 6/8 again. That's not changing. And we get 1/8 out of that, all right? So let's see what's going to happen. I'm going to get 7/8, and I'm going to subtract. Oh, yes, we're going to add those together first, right? Did you just see what I did? What was different? We add the 6 and the 1 and get our 7. And you're saying, well, Ernie, that gives us nothing, 0 over 8. And you know what that means? It doesn't mean the answer is 8. Some of my students will tell you that. Nope. Gives you 0. Gives you 0. So basically, you had 7/8 of something. I take it away from you. You have nothing left. It doesn't matter whether it's 8s, 4s, or whatever. You have nothing left. It's at 0. But did you notice with those two problems, big parentheses made all the difference. Made all the difference. And otherwise, you work the things left to right with addition and subtraction in the order, unless parentheses tell you otherwise. And speaking of telling you otherwise, I want to tell you thank you for tuning in today with Fraction Action. We've done addition, we've done subtraction, we've got multiplication and division coming your way. You don't want to miss out on that for any days. I will see you again for the very next time. Yes, sir.